Scales are subgroups of notes that go well with each other. In this case, the word well is often defined culturally, but sometimes there are mathematical concepts that help establish that metric. This video will discuss those concepts. So hello, welcome to the Botengu channel. I use this channel to show videos about music theory, others with myself playing music, and I also like to make small documentaries on African music. You can like, comment, and subscribe if you want to see more. This video will be divided into 3 parts. First, I will go over the physics behind the notes. Then, I will discuss the tuning of conventional Western musical notes. And finally, I will talk about how we derive the scales from those notes. Let's start with the basics. How does an instrument produce a sound? Well, let's take a guitar for example. When plucking the string of a guitar, the string vibrates simultaneously in different manners. We call those modes of vibration. The string can vibrate so that the middle point spans the largest distance by only being restricted at the 2 ends. That point is also called the antinode. We call that mode of vibration the fundamental mode or the first harmonic. Now let n be a positive integer. The nth mode of vibration or harmonic has n antinodes. As n increases, the amplitude of the wave decreases. The first harmonic produces a wave of frequency f1 that depends on the length, the tension n, and the material of the string. Once those factors are fixed, the frequency of the nth harmonic is n times f1. As implied earlier, notes are sound waves, and sound waves have frequencies. The Western standard notes are grouped by pitches. A group contains 12 notes. The same notes are replicated at higher pitches by multiplying the frequency by an integer. Letters from A to G are used, and flats and sharps are used in between some of those notes. The sharp of a letter is the flat of the consecutive letter in the alphabet. This is irrelevant when it comes to the mathematics of notes. The frequencies for those standard notes can be obtained using the following formula, where the base is the note A of the group 4. A frequency of 440 Hz was given to A4, and the rest of the notes were obtained from that. The index indicates how far the current note is from A4, and A4 has an index of 0. The table usually starts at C0 and can be filled by incrementally increasing IDX. Now, amongst those 12 notes, we can create subgroups of notes that we call scales. As mentioned in the intro, scales are subgroups of notes that go well with each other. To define what well means, we have to remember that when a guitar string is plucked, for example, there are multiple notes or harmonics that are played simultaneously. Notes that go well together are notes that share a lot of those harmonics. For example, C0 and C1 share a lot of harmonics since there is a frequency ratio of 2 to 1, and hence they go well together. But when going through the notes only using a ratio of 2, we just get the same notes at higher pitches. Hence, instead, we use the next best ratio, a ratio of 3 to 2. It is equivalent to going down the list of notes by an index of 7, or multiplying the frequency of a current note by the following number. If, for example, we want to have the notes that go well with C0, we start from C0 and we'll multiply its frequency by about 3 over 2 and find the corresponding note. When we get to higher pitches, we can divide the ratio by 2. We do this 6 times to get the 7 notes. Now, the notes can also be sorted based on their frequencies. The scale we find when we do all this is called the leading scale, in the key of C. It is one mode of the major scale. The notes can be put around the circle, and the polygons showing their intervals can be created. The key, or the central note of the scale, is indicated by a box. Rotating the shape without moving the key will give different modes of the major scale. For example, by rotating the polygon once in a clockwise manner, we obtain the Phrygian mode in the key of C. Rotating the shape and moving the box with it will give the same scale but in a different key. For example, rotating the polygon 6 times in a clockwise manner, such that the square is around G, will give you the leading scale in the key of G. All of this begs for a bigger question. How do we get chords from those specific scales? Well, this will be discussed in a different video.